So omega is equal to 2 into square root of alpha by m into sine of q by a. This omega is nothing but, what is the omega? Angular frequency of monoatomic lattice. Those are in vibration state. The vibrational state angular frequency. The vibrational state angular frequency omega can be taken as 2 root of wave vector, this is force constant alpha by mass into sine of wave vector lattice distance by 2. This is angular frequency. This angular frequency is nothing but cutoff frequency of monoatomic linear chain. That is cutoff frequency monoatomic linear chain. This omega value is maximum. At what condition is maximum? The sine of term must be equal to 1. Nothing but sine qa by 2 value is equal to 1. Sine qa by value is 1, nothing but q by 2 is equal to sine inverse 1. Sine at what condition is 1? Particularly 90 degrees, pi by 2. These two get cancelled. Then qa value is equal to pi, otherwise plus or minus. Then wave vector q value is equal to plus or minus pi by 2. So at what the condition wave vector is equal to plus or minus pi by 2, at that condition angular frequency value is maximum. That maximum value can be taken as cutoff frequency of monoatomic linear chain. So q value, that wave vector q value must be equal to plus or minus pi by a. According to the data, the wave vector is lie in between minus pi by a to plus pi by a. This particular region, can be called as first Brylonian zone. The volume or region in between the wave vector lie in between minus pi by a to pi by a. That wave vector lie in between minus pi by a to plus pi by a. That region can be called as first Brylonian zone of the wave. So the maximum wavelength. So according to the data, what is the cutoff frequency or maximum angular frequency? The maximum angular frequency is sine qa by 2 value is equal to 1. So omega maximum is equal to 2 into square root of alpha by m. This is the maximum angular frequency. This maximum angular frequency can be called as cutoff frequency of monoatomic linear chain. That is called as cutoff frequency of monoatomic linear chain. This is omega, nothing but angular frequency. What is the maximum frequency? What is the frequency definition? The number of waves per unit interval of time. So omega in terms of normal frequency can be written as 2 pi n. So 2 pi n value is equal to 2 into square root of alpha by m. Both sides 2 get cancelled. Then normal frequency n is equal to 1 by pi into square root of alpha by m. This is the maximum normal frequency. Of cutoff frequency in monoatomic lattice is 1 by pi into square root of alpha by m. Those are cutoff frequency. At this condition, what is the time period? Time period can be called as what is The time required to complete one wave, the time required to complete one wave or one complete oscillation with respect to simple harmonic motion, the time required to complete one oscillation, otherwise one complete wave, that is called as time period. What is the relation among the time period and frequency is nothing but the time period simply called as reciprocal of frequency. Reciprocal of frequency, that is called as time. Here we have the frequency. Then reciprocal can be taken as 1 by pi into square root of alpha by m. Then time period can be occurred pi into square root of m by alpha. This is the time period. At what the condition, cutoff condition is occurred, that cutoff condition time period can be taken as pi into square root of m by alpha. This is cutoff frequency in terms of angular frequency. This is cutoff frequency in terms of normal frequency. This is at the condition how much time is required. That condition of time period t is equal to pi into square root of m by alpha. This is the atoms are vibrated in monoatomic lattice chain. Monoatomic lattice chain. So the vibrational particles are displaced from their mean position to some other displacement. At that condition, the particles are vibrated in the form of normal mode. So in the normal mode, the vibrating particles exhibit longitudinal wave. According to longitudinal wave, those are called as plane waves. According to those waves can be called as plane waves. According to that waves existing, the equation is equation number 1. That is the equation of motion. According to your equation number 1, you can deduce the solution of the equation. Finally, you get the cutoff region of monoatomic vibrating particles can be taken as omega maximum is equal to 2 into square root of alpha by m. Otherwise, n is equal to 1 by pi into square root of alpha by m. Otherwise, time period is equal to pi into square root of m by alpha. This is the monoatomic lattice vibrations. Monoatomic lattice vibrations, particularly in the linear chain. So the base is consisting of only one atom. That one atom is vibrated. So due to the absorption of thermal energy, in that case phonons are liberated or created. Otherwise, due to collision, phonons are vibrated in the single direction, that is linear direction. So in the linear direction, the particle or lattice is vibrated in the simple harmonic motion. Nothing but continuous periodical motion is occurred. Simple harmonic motion, and with respect to two atoms, I am showing the interaction between two atoms. I am showing with respect to spring. So with respect to spring is nothing but this is the elastic vibrations are existed. Elastic vibrations is nothing but to and fro motion. Nothing but simple harmonic motion is created. According to simple harmonic motion, what is the angular frequency of the vibrational particle? The angular frequency of vibration particles can be taken as 2 into square root of alpha by into sine of qa by 2. That is the actual angular frequency. Actual angular frequency omega is equal to 2 into square root of alpha by m into sine of qa by 2. This is the actual angular frequency of the vibration of lattices in monoatomic lattice. Based on this, the maximum frequency is nothing but cutoff frequency. The maximum frequency is nothing but cutoff frequency. That cutoff frequency is occurs, this sine qa by 2 value is equal to 1. At that condition, I am deriving that value is 1 is nothing but your wave vector is lying in between minus pi by a to plus pi by a. Minus pi by a to plus pi by a region can be called as the first Brownian zone of the lattices. The first Brownian zone of the lattices. According to that, the omega maximum is nothing but cutoff frequency. Omega maximum and n maximum and time period. So this is vibration of lattice vibrations in monoatomic lattice. Almost the topic, according to the topic, is completed. But based on this, you can derive long range wavelength, group velocity, phase velocity, velocity of sound. These all are derived based on this topic only. Okay, this topic based on, you can remaining parts are completed in our next class. Okay.